In example 3, we're going to be looking at examples where we have a vertical asymptote. All right, so in this case, I'm going to go ahead and, as usual, try direct substitution. I get 1 minus 3 minus 15 divided by 1 plus 5 minus 6, which is negative 17 divided by 0. Again, not a number. This is another case of indeterminate. I can't determine what the answer is, but I can tell you that there's a vertical asymptote. So anytime we have a number divided by 0, then we have a vertical asymptote. 0 divided by 0 is always a whole. A number divided by 0 is always a vertical, well, not always, but in most cases a vertical asymptote. So we're going to work through the same idea. We're going to factor and see if we can get something to cancel out, or at least be able to tell what's going on. So when I factor the top, if at all possible, I get x minus 5, x plus 2, and in the bottom I get x minus 6, x plus 6, x minus 1. So no factors cancel out, which means there are no wholes, but as you can see, x approaches 1, and x minus 1, there's our vertical asymptote where the factor is only in the bottom. So what we need to do is we need to plug in and look at what happens at that vertical asymptote. And what we need to do is we're going to test. We're going to test on both sides to see if it's positive or negative. So I'm going to test at 1.9, and I'm going to test at 2.1. On each side of, I'm sorry, those are the wrong numbers. I'm going to test at 0.9 and 1.1. I'm going to test on each side of 1. All right, so and I'm basically looking for positive or negative. And I'm going to use these factors that I get here to tell. So I'm going to plug in a 0.9. 0.9 minus 5, that is a negative number. 0.9 plus 2, that is a positive number. 0.9 plus 6 is a positive number. And 0.9 minus 1 is a negative number. And when I multiply all that out, negative times positive divided by positive times negative, I end up with a positive value, which means that my graph on this side of the equation has to be going towards positive infinity. And I'm going to do the same thing with 1.1. When I plug in a 1.1, 1.1 minus 5, that's a negative number. 1.1 plus 2 is a positive number. 1.1 plus 6 is positive, and 1.1 minus 1 is still positive. And this ends up being a negative value, which means this side of the graph has to be going towards negative infinity. So if I'm looking at this limit, this side is going towards positive infinity, this side is going towards negative infinity. They're going to different places, so therefore the limit as x approaches 1 of this function, I'm just going to rewrite it, x squared plus 5x minus 6, does not exist. Again, it does not exist because they're going to different spots. All right, example B. Again, direct substitution. So in this case, we're looking at the limit as x approaches 2 from the positive side. So all we're looking at is the positive side, not the negative side in this case. So when I plug in a 2, I end up with 4 divided by 2 minus 2, or 4 over 0, which is not defined. It's indeterminate, but it does tell me that there's a vertical asymptote there. So what I need to do, I have a vertical asymptote at 2, and I need to test. And what am I going to test? I'm going to test on the right side or the positive side of 2, so at 2.1. Don't need to test on the other side. So when I plug in a 2.1, I end up with positive, 4 is positive, and 2.1 minus 2 is also positive, which leads me to a positive value. So on this side, it has to be going towards positive infinity. So therefore, the limit as x approaches 2 from the positive side of this function is positive infinity. All right, pause the video at this point, work on examples C and D. All right, I'm assuming that you have finished those at this point. Here is the work for those. Again, in the first case, I tried direct substitution, and I end up with 20 over 0, which is a vertical asymptote. I factor out, there's actually a hole at positive 3, which makes this problem a little bit easier when it comes time to test, which simplifies my equation to x plus 2 over x minus 2. So I test on each side of 2, and I get 1.9 and 2.1. End up with negative on the left side, positive on the right side. So because those two are going to different spots, then my limit does not exist. And in example D, I use direct substitution and get 2 divided by 0, which again is a vertical asymptote. This time I'm only looking at negative 1 from the negative side. So just to the left of negative 1 would be negative 1.1. When I plug that in, I end up with a negative value. And so since that's going to the negative infinity, that is my limit. So just as a recap, if I can use direct substitution, and if that gives me a number, then that is my answer. If I use direct substitution and I get 0 divided by 0, that means that there's a hole. I probably need to factor to remove the hole and then try direct substitution again. And if I use direct substitution and I get a number divided by 0, that to me means vertical asymptote, and I have to test on each side of wherever I'm taking a limit and decide if it's going to positive or negative infinity.